In this question, we are asked to talk about bearings. Remember, a bearing is an angle measured clockwise from a north line. So whatever that angle is over there, that will be considered to be a bearing. Bearings are always given as 3 figure numbers. So if you had a bearing of, say, 20 degrees, we'd write 0, 2, 0. Now, whenever we're doing bearings questions, we want to bear in mind that we might be dealing with trigonometry or Pythagoras as well, and also we might be dealing with our parallel line rules. North lines are parallel to each other. So we are actually creating a situation where our alternate, corresponding, or interior angle rules might be useful to us. And as and when we need them, we want to be thinking about them ready. I want to write down the bearing of port P from port R. Now what that means is that if I start from port R, so I want to measure my angle here, and I want to get to port P, what I need to do is look around clockwise from that north line. Now because we are told that this is a right angle down here, we know this must also be a right angle over here, because they're both right angles in a north line. And so the bearing I'm looking for is 270 degrees. This is part of a larger question that then goes on to ask some trigonometry and things like this, but for right now, that's all we need to do. I want to work out, oh no, there's more. I want to work out the bearing of port P from port Q. So now, over here, from port Q means I want to work out what this angle is over here. Okay? Now, in order to do this question, we're going to need to work out some extra bits and pieces. For instance, this little angle in here makes 180 degrees with the 118 degrees. So 180 minus 118 is 62 degrees in here. That means that with the 90 degrees, I can work out what the angle at the top of that little triangle is. The angle at the top of that little triangle is going to be 28 degrees, because all 3 of these would make 180. Why am I doing this? Because my bearing, being measured clockwise from north, is this angle over here. But that's a straight line, and it must make 180 degrees from that straight line. So, 180 degrees minus 28 degrees is going to get me 152 degrees, and that's the bearing of port P from port Q. Always pay attention in bearings questions to where the word from is. That's where your angle goes. AB is parallel to CD, so now what I'm doing is thinking about my parallel line rules. That has to be what this question is about. We can see over here the arrangement for alternate angles, so Y will be the same as the 60-degree angle. In this next question, we see the arrangement for alternate angles, for corresponding angles. So the value of B will also be 68 degrees, and the reason why, we can just say corresponding angles. Nothing more complicated than that. Remember the rules. Spell the word fun if we actually look at what the rule looks like. And the names of the rules spell out CIA. So have fun and join the CIA helps to remember the name for each rule. Here I can clearly see that letter F. Okay, so that must be the corresponding angle rule, because that goes first. Sometimes these rules will be flipped around, rotated, stretched or distorted, so don't expect it to look exactly like this every time. So here's another slightly more complicated parallel lines question with an isosceles triangle in it. Remember, in isosceles triangles, the 2 angles at the base of the isosceles triangle and the ends of the sides which are the same length will be the same as each other. I can also look at these parallel lines and I can see that U shape from the middle of fun and think, well, that's interior angles, and these two angles together have to equal 180 degrees. I can also see a straight line down here, and I know those two angles will make 180 degrees as well. I'll get started with the isosceles triangle. 180 minus 36 takes me down to 144. This has to be shared equally between the two sides at the base of the triangle, the two angles, sorry, at the base of the triangle. So 144 divided by 2 makes 72 degrees, and that's C. Now if this is 72 degrees on this side, and the whole thing makes 180 degrees, then I can say that D is 108, because they add up to 180. So D is 108 degrees. And remembering my interior angles rule, I can now say that E and D add up to 180. So E must equal 180 minus 108, and that gets me 72 degrees again. I could have used the fact that E and C are the same as each other. They are alternate angles. A bit of a twisted around letter N is buried in the middle of all of that. The reason why I didn't use that rule is because the interior angles rule, the letter U, jumped out at me more. But for you it may be different. So we've altogether got C is 72 degrees, D is 108 degrees, and E is 72 degrees again. Working out the size of the angle marked X, well, this is clearly the arrangement for interior angles, the U from the middle of fun, going with the I from the middle of CIA. We know these two angles must add up to 180 degrees, so X is 180 minus 111, and that gets me 69 degrees. Over here I want to work out the size of the angle marked X. Now this does not correspond to any of my rules exactly. So I'm going to apply these rules, the fun rules, the CIA rules, and see just how close to X I can get. So for instance, I can see a kind of back to front letter N going on over here. That means the alternate angles rule is going to tell me that's 59 degrees. Now with this being a straight line over here, I know that X is equal to 180 minus 59, 121 degrees. And that's it. So sometimes we don't get our angle directly, sometimes we have to take a couple of steps before we can get there. And that's a good example of that. Here's our final question. AB is parallel to CD, so once again I can use my parallel line rules. I can also see two sides that have been marked as being the same as each other, which makes this triangle in the middle here an isosceles triangle. And I'm just going to note before I begin that these two angles are the same as each other. So, I want eventually to work out the size of the angle Y, but I'm not going to rush. This angle in here is 154 degrees. Because it's kind of a warped letter N shape, it's that alternate angles rule. Now if I do 180 minus 154, I'm going to get 26 degrees. That 26 degrees has to be shared out among these two equal angles at the bottom of my isosceles triangle. So each of these little angles over here is worth 13 degrees. Finally, this 13 degrees is in a straight line with Y, so I'm going to go Y equals 180 minus 13, which gets me 167 degrees, and that's my final answer. So it said to work out the size of angle Y, giving reasons for your answer. So here's one way in which I could have given reasons for my answer. I'm going to label this angle in here as little a. I could say that little a is 154 degrees, and my reason is alternate angles. Then I could label this angle over here with a little b, and say b is equal to 26 divided by 2, which is 13 degrees. because angles in an isosceles triangle. This is all you need to write. In fact, this is more than you need to write. I'm overachieving right now. And then finally I can say y equals 180 minus 13, 167 degrees, and say angles on a line. And that will be a model answer, including reasons. And that concludes the solutions for the geometry worksheet.